Hi, this is Martin Osei Jr. In this video, I am going to show you how easy it is to set up online courses for distance learning. Then I will highlight the potential and effectiveness of Class 6.5 for scientific presentation and teaching. Note that I am using Class 6.5 for this presentation. Before we get started, let's browse through a few slides of this document in normal mode. In fact, we have three display modes, which are the normal mode, slideshow, and teaching mode. This places class one display mode higher than the traditional presentation software. Now we are currently in the normal display mode. I am now going to upload the document onto a server, and I'll need my account to do that. Naturally, you should be connected to the internet to be able to connect. I already have a teacher account, so let me log into that. Once connected, I go to File, but you can see that Upload to my web resource is currently inactive. So I'll come to the task pane and switch from Cloud Lessons to Private Lessons, and then select this demo folder, which I intend to use as my destination folder. Now you can notice that the option to upload to my web resource is active, so I click on it, and I want to upload it to demo, so I come back to task pane and click on demo, and then click OK. And in just a few seconds, your upload should be done. No matter how much multimedia content you have in it or the number of animations, class files are always so light in weight that it doesn't take too long to upload them online. So we are going to give it just a few more seconds, and yeah, it is done. We can go click on the demo folder and you can see it there. So straight away, I'll go click on the Data Application Center link, which will take me to my teaching web page. It is on the teaching web page that my online lesson is going to be conducted, and that is where I will have my students. I can distribute the document to them, I can meet them and have all my lessons there. Over here, I'll look for lessons from the top menus and then click on my lessons. And if you check from the top right corner, you can see that I am still logged into my teacher account. I give it a few more seconds for my lessons to load. Once it's loaded, I go click on demo. And once I click on demo, you can see the content in that folder. Yes, the Learning 6.5 for online courses there. I can even choose to preview the document. And just as I had it in the normal mode in class 6.5, you can see it here online as well. And just for the fun of it, I would like to just browse through a few of the slides to assure myself that the content is still intact. Nothing has changed. And you can see the beauty of it. It's all right here. Now that I'm sure everything is intact, I am going to distribute it. So I click on distribute right next to preview. When I click distribute, it gives me my class list. I can choose to distribute to all, that's by selecting all, or I can choose some specific students. So I choose student 1 and then Aminata. The name of the file is also there. Then I go click on distribute. And I've been prompted that this has been done successfully. As at this point, the students can have access to the document. So I am going to exit the teacher account so that I can log in now as a student. So let's exit. Oops, there was no need to close the task pane, but don't worry, when I open a new class document, I can bring back the task pane. So we close this class file and then open the class application all over again from our desktop or anywhere it's located on our computer. So we wait for it to finish opening, and when it opens, you'll notice that the tax pane is not there because we closed it in the previous file, and we can easily bring it back. We just have to click on the tax pane icon just like this. So now in the tax pane, I log in, this time as a student. So I'm using my student account. Take note that I have created all these accounts in advance for the purpose of this demonstration. And when I click login, you can see all the courses that as a student I have access to. I am looking for this course, that's the first one. So I double click on it. And by it, I mean this Learning 6.5 for online course, the very last one I have just received as a student. And as I've double clicked on it, it opens for me, it loads. This is online, so it has to download it. It loads up for me. And straight away, I would like to move to slideshow and just see the beauty of the slideshow. And just like the traditional concept, with just a click, I move to the next slide. In fact, Learning 6.5 system is a combination of network technology and a revolutionary and versatile software suite that does not only facilitate the creation and operation of a digital virtual school, but also the processing of any type of scientific document, the creation of all kinds of presentation or science teaching slides, and distance learning and assessment involving various types of mathematical sciences using the computer. And this technology is available for any school, institution, or individual who wants it. Upon request, it can be made available on your servers. The software suite is also made up of ScienceWord, Class, Skill, Marking, and Symptom. Alright, let's move on and see this revolutionary concept of text animation and teaching mode in class 6.5. Here, you will notice that it's even possible to animate text in a table and even insert objects into the table. You can see there is no limitation to what you can do with class 6.5 when it comes to presentation. Okay, so now let's end this show and move straight to teaching mode, where we are going to see another powerful feature of class 6.5 when it comes to presentation. This is the teaching mode. And what is the difference between this and the normal slideshow? Let me start with the whiteboard toolbar. Here I can customize it. The items I don't need here, I can take them out and bring in the ones that I need. But in this case, I'm okay with exactly what I have here, so I leave it as it is. In the teaching mode, while still presenting, I can still edit my document. Maybe in the course of my teaching, I want to now indicate that this is a statistical graph. No problem. I can just type it in there whilst I am still presenting. I can even choose to write a formula, and let's say I can go and just bring my toolbar that I need for this purpose. So I bring up my format toolbar where I can activate Intelligent Adjust. So I can even type my function in all the possible ways allowed in typing functions in class and then science word, including the use of the fast input option. If you've been watching our previous videos, then you are already aware of how the fast input option works, where you can use the names of functions to pull them up whilst you type. A very revolutionary manner of writing scientific documents. Even if I want to use the pen, I can also pick the pen tool and write the same function. F of x is equal to fraction 1 over x minus square root of x minus 2. And if I make a mistake, I can use the eraser to rub off what I don't need. And if I want to zoom in and concentrate on just one particular aspect of the slide, I just have to magnify as appropriate and drag the red rectangle to the portion I want to concentrate on. I don't need the eraser again, so let me just take it off. Okay, so let's say I now want to concentrate or highlight on the statistical graph. So I just hold the red rectangle and drag it to the statistical graph. So you can use this tool to lay emphasis on any particular aspect of the slide that you are currently working in. This will avoid your students being distracted by other content on the slide if you are trying to explain a particular content, one specific content on the slide to them. And once you are done explaining this content, you just have to close the magnifier and then you are back to the normal view. Now we can decide to move on. Just hold it and drag it to the left and it takes you to the next slide. Okay, so right here you can see that all elementary school vertical calculations are possible right here in class 6.5. All the operations in different formats. Okay, so to show you how this is done, I am going to add a blank page and then pull up the arithmetic dialog box. And in the expression bar, we can type any operation at all that we want to perform, be it addition, subtraction, multiplication, division, factorization, any of them at all. And even after performing, let's say, this division, I can even go duplicate it, go to its properties, and then customize the division. So let's choose French division for the duplicate and confirm. And this is just nice. Okay, I think I'm satisfied with what I'm doing here. So let's move on. And on our next slide, you will notice that I can even animate. And this animation is highlighting the various steps in this basic school multiplication. All right, now let's move to the next slide. Here we are talking about the simplicity of writing mathematical expressions and simple chemical equations like ordinary text. For the sake of time, I am just going to move on, but you can pause the video and savor the moment. All right, in our next slide, editing chemical structures and equations. And we can even go and look at some animations of some chemical reactions. And here you can see how the formation of carbon dioxide molecule is done. The formation of a covalent bond. I can even customize, take off my standard toolbar, my formatting toolbar, and bring up other ones that I may need. Let's customize our page this way so that I can have my slides on the left hand side. So the format toolbar is off and I bring the standard toolbar. And then I show my slides on the left so that I can easily skip through to the right slide that I'm interested in. All right, this is the construction of a helix as shown here. Over here, we are also separately showing various elements of the construction. The animation serves multiple purposes. Here we are referring to just one, which is the significance of the parameters S, R, A, B, and C. Yes, so this very same construction animation could be used in several other lessons where other parameters could be our interest. It just depends on what the lesson is interested in, the objectives of the lesson. For the purpose of this, our lesson, we are just interested in the significance of the aforementioned parameters in the construction of the helix. Okay, so we can stop the animation and move on to our next slide. Here we can talk about hypocycloids and symmetrical curves that are related to a varying axis. I am laying emphasis on a varying axis. The varying axis here is AI. Even though the axis is varying, symmetry is never missed. You can even choose to change the value of K and see the result. But anyway, let's just move on. When you have the file, you can investigate further by changing the values of K. In our next slide, you can see the direction of the force as it changes back and forth as the spring and the trolley moves up and down. You can see that the arrow was pointing downwards when the weight was pulling down, but then when it tends to move up, the arrow changes upwards. Alright, so this is also some learning tools that the teacher can use to facilitate his teaching of angle transfer. You wouldn't need to explain too much. Just by watching this, most students can grasp the concept you are trying to put across. Learning 6.5 is here to make the work of the teacher less burdensome and rather convert abstract concepts into more realistic and fun to learn. The student is definitely going to enjoy what he learns when he sees easy constructions like this. When you are done, you can choose to clean the unneeded construction marks. Okay, so in our next slide, we see some animations of some function graphs. When we look at the application of the arc motion on the curve, you can see that the green arc is moving on the red curve, while the yellow and red arc is moving on the blue curve. When you have sufficiently explored the behavior of the animation, we can pause it and move on. Next, we look at the animation of the Lagrange polynomial passing through 6 variable points. And if we take the point to be Pi, Pi has coordinates xi, yi. Here we can explore this function very well, and if you go down here, you can see the coefficients of Lagrange. And how do we get that? Let's show it. Yes, this is the formula. I can double click on A5 and go to functional variable, and you can see the function that was used right there. Okay, so I can hide it once again. Let's take a look at A4 also, and yes, we can click OK to go back. Okay, let me skip to A0. Yes, they are all there. All of them, the functions are available. And all of these depend on xi, yi. Okay, so let's suppose that I want to change the x1 value. Let's say I want to change x1 value to -4. So I click here. And once I change it to -4, you can see that the position of P1 will change. And everything else is updated automatically. Okay, now let's move to the motion properties of this curve. And using Lagrange coefficients, as you can see, A5, A4, A3, and so on. Alright, so I click OK and move on. Okay, so some simple experimental setups. A complex electrical circuit animation. In this animation, it is a timed electrical circuit. When t equals 1, the switch will start closing, and within an interval of 2 seconds, it would have fully closed. So by the time t becomes 3, the switch would have fully closed. And as you can see, it is gradually closing. And for the circuit at the top, when t equals 3, the circuit will start closing, and within an interval of 1 second, it would have fully closed. So by the time t is equal to 4, it would have fully closed. And if we wait just a little while, when the switch fully closes, we can now see current flowing through. Yes, there we are. The current is now flowing through. And the circuit at the top has also started drawing closer, trying to close up. So yes, it keeps going closer and closer until finally it closes and you can see the bulb light up. All right, now let's move on to some learning objects in higher education. This is a photo ejection, and this animation highlights how X-rays are produced. When inner bond electrons are ejected from an atom, leaving a vacancy. Replacement of vacancy by electrons from higher orbits lead to emission of characteristic X-rays. Okay, so this is another example of a higher learning object. Alright, so now let's switch to technical education. Class 6.5 software is a very powerful tool for teaching technical drawing. Just watch this animation. Apart from your students understanding abstract concept better, your lesson is also going to be more interesting when they see such animations. I can even change the pace at which it moves. I can increase the speed. I can accelerate the pace at which any of the parts are moving. And when you have such a powerful learning resource with just a little explanation from the teacher, everything becomes clear for the students to understand. Next, we take a look at the vernier caliper. And the item to be measured is supposed to be set in the caliper, and because it's not yet done, it says measure conditions are not set properly. So let's set it up. And when you click on set, it's now in the caliper, so we can click take object measure. And take note of how the caliper is operating. As there is a horizontal displacement, there is also a vertical rotation. This is just amazing. Yes, and it keeps moving until it finally holds the object to be measured. And when it finally holds the object to be measured, you can see the size as it displays there, 0.223 centimeters. Alright, so next let's take a look at this geography application, the globe and its measurements, longitudes and latitudes. Let's show the other part of the meridian. Okay, so now let's animate it and then even increase the speed a little bit. Let's watch the meridian carefully, both the part showing in straight line and the part in dotted line. When the hidden part finally comes to the surface where we can see, it's now in a continuous line. And the one that we could see, once it goes behind that we can't see again, it changes to dotted line. Okay, we can stop the meridian's movement now, and we can even animate the latitudes as well. There are so many more that we don't have time to show. In real life, we can plot even coordinates on this and it will take us right to where it is supposed to be. Okay, let's move on. Let's now look at some practical applications of animation in solving an optimization problem. A system of inequalities are all going to be drawn on the same axis and their common intersection which is the solution region, can so easily be identified. On the right hand side, we can see the analysis of their problem, and we can see all the steps involved in solving the problem. And now you can see the red line being drawn and the solution region as it moves towards the right. And we get all of these in different colors so we can easily identify the differences between them. Now y equals 0 is also being drawn as we speak. And the required region is shown up here as well. This is obviously just mind-blowing. There is not much I can say here. You see it for yourself. There isn't too much. I wouldn't like to talk too much here. Let's just move on. Let's show just a few more things. Let's see which one should I pick next. All right, let's get to this slide where we are going to show the development of a cylinder and how it can be broken down into its net. So this cylinder is going to be totally unfolded, and it will become easier for students to understand how the surface area of the cylinder is calculated. We can increase the speed a little bit so that it can finish early. So you can see the circumference becoming the length of the rectangle, and the height is the breadth of the unfolded rectangle. And because it's unfolded from the cylinder, it is easier for the student to make the link between the two-dimensional rectangle and the solid cylinder. So surface area is equal to circumference of the circle at either ends times the height of the cylinder. Okay, let's see this one also, which is the development of a cube. Here in total we have 11 sets, and we can animate any one of them at any point at all. Let me just add some speed and just observe the beauty as the cube forms up from its two-dimensional net. Your students are definitely going to enjoy your lesson if you can integrate this in your class. Just see the beauty of it. Mathematics is now an interesting course to study. Okay, so this one is done. We can take a look at other forms. As I said, there are 11 different ones in here. I can either move step by step through them, or I can even decide to just jump to a particular one. Okay, so fine. Let me go and pick the 11th one. So number 11. Then I can play through the animation process just as we've seen for the previous ones. This is also the same. It will show us the formation of the cube from the net. You just have to play this for your students whilst you give them very little explanation, and they can see it and understand it all for themselves. Little work for the teacher, better understanding for your students. And interestingly, we can decide to go and have a look at a specific time. How will the shape look like at a specific time? For instance, when it is t is equal to 3.2, how will the shape look like? All right, let's move on to another learning activity. This is a high school activity which also goes to further deepen understanding of concepts that otherwise would have looked too abstract and difficult for our students to understand or comprehend. So let's take this and enjoy our teaching and learning better. Okay, so thank you so much for watching this presentation, and as usual, you can find additional resources on novatest.com and scienceoffice.com. As usual, I am Martin Osei Jr. Bye for now.